All right, today we're going to talk about a technique that is a real game changer for getting smarter, way more accurate answers from AI. It's called chain of thought prompting. And honestly, it might just change the way you talk to large language models for good.
So here's the game plan. First, we'll break down what chain of thought or COAT even is. Then we'll dig into the fascinating reason why it's so effective. After that, we'll get practical with a toolkit you can use, cover some pro tips for tricky situations, and wrap it all up with a much-needed reality check for where AI is today.
Okay, let's kick things off with a problem I know you've run into. You ask a super smart AI a pretty simple logic question, and it gives you an answer that is just confidently wrong. How does that happen? Well, that's the exact frustration that chain of thought was born to solve.
So what is this magic technique? Well, at its heart, it's all about a simple idea you probably heard a million times in school. You gotta show your work. Okay, so here's the official breakdown. Instead of just jumping to the finish line and asking for the answer, you're actually prompting the AI to, well, think out loud, to lay out the intermediate steps. You're basically telling it to build a logical bridge from the question all the way to the conclusion. And this analogy just hits the nail on the head. You don't just care about the final number. You want to see the whole process, right? This not only makes the answer way more trustworthy, but it also lets you see exactly where the AI's logic might have taken a wrong turn.
But here's the thing. This isn't just a neat party trick. There's a really fascinating reason it's so incredibly effective. So let's get into the why. Why does this simple tweak actually work on a deep, fundamental level?
It really boils down to three key things. First, it kind of mimics how we humans think, one step at a time. Second, it helps the AI get over what researchers call illusionary competence. That's when an AI can write a beautiful poem, but completely fumbles a basic word problem. It sounds smart, but its reasoning is actually pretty brittle. And third, and maybe most importantly, it forces the AI to break down a big, complex problem into smaller, bite-sized pieces it can actually handle.
And this process, this idea of decomposition, it's the secret sauce. It taps into these incredible emergent abilities that these huge models have. These are complex skills that nobody explicitly programmed in. They just sort of appear when the model gets big enough. By making the AI break a problem down, we're giving it the structure it needs to actually use those powerful, hidden talents.
Okay, now this next part, this is a mind bender. It's a huge insight from Google's original research, and it's probably the most important thing to understand about this whole topic. When you give an AI examples to follow, it's learning from the pattern of your logic, the structure of your reasoning. It doesn't actually care if the final answer in your example is correct. Let that sink in for a second. You're not teaching it the answer, you're teaching it how to think.
All right, theory's great, but how do you actually use this stuff? Let's get our hands dirty and open up the toolkit you can start using right now. So you've basically got two main flavors of this. The first is called Few-Shot Caught. That's where you feed the AI a couple of complete worked-out examples, question, step-by-step thinking, final answer, before you give it your real problem. Then you've got Zero-Shot Caught, which, as the name implies, needs zero examples. You just give it a simple instruction.
And believe it or not, sometimes this incredibly simple phrase is all it takes. Seriously. Just tacking on "let's think step by step" at the end of your prompt can be enough to kick the AI's reasoning abilities into high gear and totally transform the quality of its answer. It is the easiest, most powerful trick in the book. This table lays it all out pretty clearly, so let's just walk through it. You'll want to use Few-Shot QT when you're dealing with standardized problems like math questions or logic puzzles, where you can easily provide really good examples. For pretty much everything else, for quick tests and general use, Zero-Shot is your go-to. And then there's this third one, Auto QT, which is a bit more advanced. It actually gets the AI to create its own examples, which is super useful if you need to scale this up. So what happens when "let's think step by step" just doesn't cut it? For those really gnarly, complex problems. Well, for those, we have a couple of advanced techniques up our sleeve.
We're going to look at two of them. First is self-consistency, which is all about the power of a consensus. And second is least to most prompting, which is perfect for problems that have other problems nested inside of them.
So this first technique, it starts with a really simple idea. Instead of asking your question just once, what if you asked it, 5 or maybe even 10 times?
That's the core idea of self-consistency. You run the exact same prompt over and over again to get a bunch of different reasoning paths. Then you just look at all the final answers and take the one that shows up the most. It's basically like taking a majority vote from a committee of experts. It smooths out any randomness and gives you a result that's way more reliable.
And this perfectly illustrates our second pro tip. For those really complicated nested problems, you do it in 2 steps. First, you ask the AI to just break the big problem down into a list of smaller sub-questions. Then, step 2, you have it answer each of those smaller questions one by one, using the answer from the previous step to help with the next one. It's a really powerful way to build up to a complex solution from simple pieces.
Okay, so we've covered the what, the why, and the how. But before we wrap up, we absolutely need to do a quick reality check because, as you know, the world of AI is moving incredibly fast.
Here's the deal. The effectiveness of chain of thought prompting isn't some universal constant. Its value really depends on which specific AI model you happen to be using.
Just take a look at this comparison. For standard models, like a GPT 3.5, using Claude gives you a massive accuracy boost. It is absolutely 100% worth doing. But when you look at these brand new reasoning-optimized models, it's a completely different story. They kind of have this step-by-step logic already baked in, so forcing them to show their work can actually be redundant and just add extra cost and time for almost no benefit.
So the crucial takeaway here is this. You've got to know your tool. Chain of thought is an absolute superpower for most of the models out there right now, but as the technology pushes forward, the most advanced systems might not even need it.
Now, that being said, for countless practical tasks that you and I face every day, we're talking everything from math problems and logic puzzles to just basic common sense questions or planning out a project, chain of thought is still one of the absolute best tools in your prompting toolkit.
And all this leaves us with a pretty fascinating final question, doesn't it? As these AI models get more and more powerful, is our job of prompting them going to get simpler? Or are we just going to have to learn new, even more sophisticated ways to guide their thinking? Definitely something to chew on as you go out and experiment with these techniques.
All right.